In this video, we're going to continue on our discussion about scripting under Bash and do some more advanced scripting. Previously, when we looked at scripting, the idea of creating a script was simply to kind of automate our common tasks that we were doing quite a bit. Oftentimes, this included just simply, writing out the tasks that we were running and putting them in a file, and then they would just run one right after another. However, sometimes that isn't quite enough to meet all of our needs. Sometimes we want to run one task and sometimes we don't. So we have to put in some sort of what's called logic in there that can help us make these yes-no decisions. And so that's what we're going to talk about today. The very first thing we're going to talk about as far as logic is called an if-then statement. If there is ice on my windshield, then scrape windshield. It's just that simple. If the lights are off, then turn them on. If the tire is flat, then inflate it. If there is no ice cream, then go to the store. It is pretty much just that simple. If and then. That is how our very first logic statement works. Now there's lots of different logic statements. These are specifically called conditional logic statements because it depends on various conditions to determine what happens in the end run. So that's what we're going to work on here is we're going to create our very first if-then statement for conditional logic. So let's go ahead and create our first script. So using vi, let's call this testif.sh. Go ahead and go into insert mode, and we'll start off as always with our bin bash, our shebang, and our comments. Performs if-then statements. And the first thing we're going to do is we're going to write something out to the screen because we want to give the user a prompt and then ask them for some input. So we'll go ahead and start up with echo of what would you like to see? And then I'm not closing out the quotes there. I'm just hitting enter. And then today's date with a D in brackets or currently logged on users with a U in brackets. And then enter your choice. D or U. There we go. So what this does, we'll actually just save this really quick and run it. So chmod +x test if, and then we run test if, and it pretty much just prints everything out exactly the way that it was written. Remember when we wrote this, we started off with a set of quotes over here and the ending quotes right there, and therefore everything in between those quotes, including these carriage returns, were captured in those quotes and therefore printed out onto the screen for me. Oops. So let's go back in and edit that. So that's the echo statement. We could have written this out as 5 different echo statements, starting with echo on the very beginning of every single line. That would have gotten a little tedious. All right, so I've gone ahead and I've written this out, written out the prompt to the end user. Now I want to use the read command in order to get an answer. Remember, read will read from the input from the user and then store that into a variable, in this case, the variable called answer. So now we're going to start with our if-then statement. So if, and we get a little funky here with some square brackets and answer equals D. The square brackets just help identify. We want to look at the contents of what's inside of those brackets. Then And this isn't strictly necessary, but I'm hitting tab here in order to indent. You'll see as we go on, the indentations actually make it easier to read, even though it's not strictly necessary for the computer to read it. It's just for us to be able to read it. So I want to echo today's date is, and then run the date command. And at that point, that is my if and then statement. I'm actually going to leave it right there. We're only going to look at the date at this point. In order to end the if statement, this always makes me laugh. We start the if statement right here with if. Well, if that's how we start it, how do we end it? Well, we kind of write it backwards. We write phi. So if starts it, phi ends it. There is no fo and there is no fum. Yeah. Okay, so I'm going to go ahead and save that, and then we'll run it. And it prompts us and is now asking us for our answer. Now, currently the only answer that we have configured in there is D. So I'm going to go ahead and choose D and hit enter, and then it spits out the date. Now, there's a couple of issues here. First off, U doesn't do anything, so we still have to fix that. So if I run it again and type in U, nothing happens. The second issue, however, is if I type in uppercase D. Up above, we did a lowercase d. Here, if I do an uppercase d, still nothing happens. Our if statement was looking for a lowercase d, so we can actually tweak that to allow an uppercase d as well. So I'm going to go back into my vi command and do just that. So here I'm at the if line again, and what I'm going to do is after the lowercase d, I'm going to do a -o standing for or, and then answer equals quote uppercase d. And in this case, both a lowercase d and an uppercase d will work. Now I can continue on this -o in order to include other options. However, just 2 should be sufficient to show that an uppercase that we can put multiple options on that same line. Alright, so we've got our date in there. Now let's go ahead and do something for our other users, and this is where some of the more complex if-then features come in. So we had if, and then we said then, and we did something. However, sometimes there's more than one possible answer. If the lights are on in my house, then turn them off. But if the kitchen lights are on, but the living room lights are off, then leave them on. If all the lights are off, then make sure that the night light's working. There's a whole lot of if-thens, a lot of different options in there. And I could stagger these as having a whole bunch of if-then. However, that gets a little tedious. Having a whole bunch of if-then phi, if-then phi, if-then phi. What I could do instead is I could in fact use if then, and then what's called elif. So else if then. And so what it does is it compares this very first option here, compares this very first if statement here, and then it does the next command. If that first if statement does not match, then it will start evaluating the second statement. And then if that one doesn't match, then it will evaluate the third and the fourth and however many statements we might possibly have. So let's check that out with our users. There we go. So what I'm going to do is I'm in insert mode. I'm just going to push this phi statement down further. We still need the phi at the end, but we're not there yet. So we just did our first if statement. Now we want an elif, E-L-I-F, for else if. And then we do the same thing as what we did before with $answer equals, in this case, lowercase u, or $answer equals uppercase u. echo the currently logged on users. And then we run the who command. And it should be just that simple. Remember, what's going to happen here is it's going to come along and it's going to evaluate this statement. Is this statement true? If so, then run this. However, if that statement is not true, then and only then will it evaluate this statement. And then if that one is true, it will run this. If that's not true, then it could go on to a third or fourth or fifth or 100th additional if statements. So let's go ahead and run this. And we already know that D works. We can actually try that just again, just to make sure D for date works. And then U for users, both lowercase and uppercase works. Great. So we're getting there. We still have another weird situation where if I type in something completely wrong, it just gives me an error. Well, first off, it gives me, it doesn't like the fact that there's two items in there. So if I just type wrong, there we go. If I just type wrong in there, then it gives me nothing back. It would actually be helpful if there was some way for it to be able to tell me, you know what, you did not give me a valid option. So let's do that last one. Let's type it so that it will actually tell me if there is an invalid option included. And this is where the final function of the else, if the if then else if statement comes in, which is just simply else. So we can, at the very end here, we can type in an else statement and it will run that if everything else has been evaluated as untrue or false. So for that, let's go ahead and come on down here and just type in else. There's no evaluation here. We just simply type else. And then we type echo wrong options chosen. Go ahead and save that and run it. And now if I type in a wrong option, it tells me my wrong options are chosen. So it tells me if I've gotten the correct option by returning back the answer that I'm looking for. And if I type in anything else, such as the number 7, it tells me I typed in the wrong solution. Awesome. So at this point, I can continue to edit this script and I can add in more and more functions. For instance, before this else statement, I can also type in, actually I should before here, let's type in my echo, let's type in the contents of the / directory. And we'll call that R. And then down here, we'll add R as another choice. And then finally, we'll do an else if answer equals R or answer equals R. Then echo the contents of /R and then ls/. And so there we go. Now we can just keep adding on more and more to our script, and suddenly we have a very in-depth script that keeps working for us, and we can keep growing it as we need. Do we want to add a user? Do we want to add a group? Do we want to reboot the machine? Do we want to change the date? Do we want to, all these different tasks that we can have it do, and it can all prompt us in a custom script that we write. All right, so that's looking pretty good. If I read that script, you can definitely see here where the indentation is starting to make it a whole lot easier to read. However, if we keep this going, all of these else-if statements could become a little complex. In order to circumvent this, what we can do is we can use a different conditional statement, which is called case. what case does is it evaluates something such as answer. So we would say like case $answer. And then we would say, here's our first option, for instance, D, parenthesis. And then if the answer is D, then do X. If the answer is U, parenthesis, then do those functions. And if it's R, then do those functions. It makes it a little bit easier to read when you have a whole bunch of if, then, else statements all together. Ultimately, the case statement actually is a little bit faster because it evaluates it. It evaluates it right here one time. The if-then statement, however, evaluates it right there, and then evaluates it right there, and the else statement is the last one. So in this case, with the case statement, we're evaluating the answer variable one time. The other, with the if-then, we're evaluating it 3 times. So it is, in fact, a little bit faster. In order to show this, what I'm going to do is I'm going to go ahead and copy my test if script, and I'm going to call it test case. So CP for copy, test if into test case.sh. That's going to copy the contents and the properties, so it's already executable. And then let's go ahead and edit test case. Now at this point, we should probably update our comments here. So it performs a case statement. Our echo and our prompt for the answer is still correct. It's only once we get down to the if statement that things start changing. So I'm going to move this down a couple of lines just to give some room to start working. And I'll start off with simply case, $answer, in. Now, obviously, I'm having problems typing the word answer, so this is really helpful because that's the last time I actually have to write it. All right, so in case of answer, indenting again, just simply in order to make things a little bit easier to read, I'm going to say for D or capital D, then echo. Nope, actually, I don't need to type echo. I can simply, I can delete some of these lines and use the echo that's already there. There we go. Now, I do have to actually define some way to be able to say that this is the end of the D option, and in order to do that, I do a double semicolon. So what happens is when D is chosen, it comes along and it starts running these lines. It runs that line, and then it runs that line, and then it runs that line. This double semicolon tells me this is the end of the case statement. At that point, exit out of the entire case statement altogether and don't come back. So my next case would be you. You or you. And again, because I'm editing a copied script, I can go ahead and just start deleting the old lines. And then add in the double semicolon again to say that this is the end of you. And then lastly, R and R, R or R, excuse me. And then for the very last option, for the invalid choice option, what we do is we simply do a $sign, a star. A star means a wildcard, and that is exactly what we're doing here. Is we're saying, hey, for everything else, for everything that doesn't match what I have up above, then go ahead and echo wrong options, or invalid choice, or you suck, or whatever. However you want to say it. Now, what we have left here is we have a phi statement. Remember, we started off with an if, and then that ran all the way to phi. We got rid of our if, and we now have a case. And that will run all the way until we find, wait for it, an ESAC. Gotta love how some of these people came up with some answers here. We start with if, we end with fi. We start with case, we end with esac, which is, if you're a little slow there, that's case spelled backwards. Yeah. Unfortunately, they don't do this in a whole lot of bash scripting, but with if and case, it's one of those like, wow, that's so elegant. That's such an interesting way to do things. Okay, so now we should be able to go ahead and save this and then run it. And at this point, the execution of it was going to probably bore you to tears. Oh, I made a typo. Unexpected EOF, looking for match. All right, let's see what that is. It says line 27 and line 31. What am I missing? Ooh, I've got an etchy. And I'm missing a set of quotes. There we go. That right there. So, first off, I had a typo right here. I wrote etchy instead of echo. And then secondly, I had this quote, but not this quote. And so that really messes things up. It's like you're saying, hey, this other person said, and then never saying what they didn't, the end of their statement. So you're saying, here's the start of somebody else's statement, but then never saying where the end of it is. So that would really, really mess it up. Let me glance really quickly, see if there's anything else. That should hopefully be it. Oops. All right, D. Yes, okay. So when it's typed correctly, D, U, and R all work exactly the same way that we expected them to work before. The case statement works very, very similar to the if-then statement. However, it is a little bit faster and sometimes a little bit easier to work and understand than the if-then statement. All right, so those are our two conditional statements. While we're here, I want to talk about one more thing, which is called a while loop. A while. And the way this works is you've been bad. You were a child, you did something bad, you ate the candy bar when you were told not to eat the candy bar. And so your mom decides to say, while this timer is running, then do something. Sit in corner. So your mom puts a timer on, their egg timer or kitchen timer or something like that, and says, until this dinger goes off, while this timer is still running, you have to sit in this corner until it stops running. When it stops running, you are done. And so what happens is you evaluate this probably every single second as a little child. What you do is you are sitting in the corner and you look up and you say, is the timer running? Question mark. You look and you see, yes, the timer is running. So you get a frowny face. Aww. And so then you sit in the corner. And then a couple of seconds later, you look back up. Is the timer running? Oh, now you get some tears coming out of your eyes. And you keep sitting in the corner. And so this while statement keeps happening. As long as this statement is true, you are going to keep doing everything that is in that loop. So that's everything that's done, it's in between the do and the done statement. You're going to keep doing it over and over as long as that first statement is true. And so this can actually be what's called a one-liner command. For instance, I could just do this right from the command prompt. While true. Now, obviously, we're going to look at this and say, well, true is always true. So yes, while true is true. So yeah. So in theory, this loop is never going to end. But if I do an echo hello world, and then let's say sleep 2, Hopefully that will sleep for 2 seconds and not 2 milliseconds, and then done. Very quickly, what I've done here, these semicolons right here count as what would be a carriage return in most scripts. So I could actually write this out in multiple lines. This would be line number 1, line number 2, 3, and then 4. However, the semicolons allow me to type it all on one line. It's awesome how it does that. So while true, which is always true, it's going to go ahead and it is going to echo out, hello world. It is then going to sleep for 2 seconds. Once we get to done, it's going to reevaluate, is true still true? If so, keep doing all of this over and over and over. Let's check it out. There we go. That was about 2 seconds. And it just keeps writing over and over and over. This can be fairly helpful if you're trying to ping if something is online, or if you're trying to see if a file is there, or constantly like refreshing a web page to see when it's something on sale shows up. These loops allow us to keep looking over and over. Now, right now we're stuck in a loop. How do we get out of it? And the answer is Control C. On our keyboard, we hit Control C, and that will cancel us out of the script, of our one-liner. So let's try that with a script. So I'm going to create a script called echo repeat.sh. Start it off with our shebang and our comments. Uses a while loop to echo. And I'll actually start off with something just as simple as what we just had. While, and let's just say true. And then do, and again, I'm going to indent it for readability only. It is not necessary. All work and no play makes Jack a dull boy. I'm going to add in a sleep statement in here. I'll sleep for 1 second between them. And then at the very end, I will go ahead and type done. So what this is going to do very briefly is it's going to go ahead and it's going to evaluate this line. Is this true? More specifically, is this true? And the answer, of course, is yes. True is true. While it's true, go ahead and start at my do line and do everything in the do section. That's why the indentation makes it so easy, so we can see exactly where the do section is. When we get to done, it's going to reevaluate. Is true? Is it still true? If so, it will keep running it. If not, it will simply continue down the script. In this case, there's nothing further down the script, so it will exit out. Now, we know from just seeing this on the command line that this is not going to do anything. I'm sorry, this is going to simply rerun this command over and over and over, but let's go ahead and check it out. Let's make that executable and then run it. And we see Jack starting to go a little bonkers. All right. To cancel it again, I hit Control C. Control C does not necessarily make true untrue. It just says stop running the script. So let's add in a little bit more into that script. Let's actually add in some logic that stops it from working automatically. For that, I'm going to insert a variable called counter equals 0. Slight side note, I have here counter equals 0, and you'll notice that there are no spaces. Ooh, very bad handwriting. No spaces around the quote. Counter is connected to the quote. The number 0 is connected to the quote. There are no spaces in between there. If you put a space in there, it will not work. I've caught this several times. I've run into it way more times than I want to admit, but it happens. Okay, so while the counter now equals 0, what I want to do is I want to change my while statement to an evaluation. I don't want to just while true. What I want to do is I want to say while $counter is less than 7. Dash LT stands for less than. You're probably thinking that what other things could we be doing here? Well, there's a dash GT. There's a dash, I believe it's LE for less than or equal to, dash GE for greater than or equal to, and then a dash EQ for equal, and then a dash NE for not equal. I am pulling these off the top of my head. I believe these are correct. Confirm before you use them. Don't take my word for it. Look it up in the book. The book is always correct. Okay, so while counter is less than 7, and right off the bat, counter is equal to 0, so it's going to start running. What I want to do now is I want to come down here in my do statement, and I want to add a new line, and I want to increment counter. So we start off with counter equals 0. I want it to go ahead and echo out all work and no play makes Jack a dull boy, pause, and then increment counter from 0 to 1. There's lots of ways to do that. The way that I found works best is to type in counter equals and then do a backtick. Quick note about the backtick. This is not a single quote. This is not a double quote. This is way up in the upper left-hand corner of your keyboard, right underneath the escape key, is a backtick. In fact, the key you're looking for is going to have most likely a tilde and that. And that backtick right there is the one that we want to do. What the backtick does is it says go ahead and run the command inside this backtick. Run the command inside of this and then return that as a value. So what we want to do is we want to run the expression $counter plus 1 and then another backtick. For those of you who really hated math, you may have seen, 1 plus 2 times 3, and that my pluses and my minuses are horrible there. 1 plus 2 times 3. What the backtick does is it's similar to the parentheses that we see in math, where you would simply put parentheses around something and it says do this first. In this case, the parentheses say add 1 plus 2, which is 3, and then multiply by times 3. The backtick says run this expression inside and then return the results to the variable called counter. Alright, so what this should do, hopefully it will go ahead and it'll run through the first time and it will increment counter to 1. The second time to 2, 3, 4, 5. Eventually it will get to 7 and then it will end out. So let's go ahead and run that. And we should get exactly 7 results. 5, 6, 7. Look at that. So that is your introduction into conditional logic and loops. 3 different scripts. Follow along, try them yourselves. It's always going to be typos that are problematic. So good luck with those. If you run into an issue just like I did on the one script, review it. Look for missing characters, look for missing quotes, look for typos, and you'll be doing great.